Let's explore counter design, specifically focusing on up and down counters. This discussion will cover the implementation of reversible counting sequences for bidirectional counter circuits. We'll start by understanding the basic types of counters. First, we have the up counter, which increments its count value with each clock pulse, essentially counting upwards. Then we have the down counter. It decrements its count value with each clock pulse, counting downwards. Now let's dive into the concept of the up-down counter, also known as a reversible counter. It is a single counter circuit capable of both incrementing and decrementing operations. A key feature of the up-down counter is a direction control signal that determines the counting mode, either up or down. Let's see how the control signal is implemented. In up mode, when the control signal is 0, the counter increments. In down mode, when the control signal is 1, the counter decrements. Now we'll look at the JK flip-flop implementation for an up-down counter. The logic can be defined as J equals K, which equals Q bar of n-1, exclusive ORed with up or down. Here, if up or down equals 0, the counter counts up. If up or down equals 1, the counter counts down. Q bar of n-1 represents the complement of the previous stage output. Here's an example of a 3-bit up-down counter circuit implementation. We have 3 flip-flops FF0, FF1, and FF2, representing the bits Q0, Q1, and Q2. A clock signal is connected to each flip-flop. The up-down control signal is provided at the top. The outputs are Q2, Q1, and Q0, with Q2 being the most significant bit and Q0 being the least significant bit. Now let's look at the truth table example for a 3-bit up-down counter sequence. In up mode, the counter increments from 000 to 001, and then to 010. Switching to down mode, the counter decrements from 010 back to 001, and then to 000 before wrapping around to 111. Finally, let's discuss the applications and key benefits of up-down counters. Applications include digital clocks and timers, motor control systems, memory address generation, and frequency dividers. The key benefits are bidirectional counting with a single circuit and simple control signal implementation. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.